Hello everyone, welcome to this video having a look at part of the new GCSE content, which is problem solving questions, and in particular using algebra to solve problems where it isn't obvious the maths that's involved in the question. So we're going to look at a couple of questions, a shape one here and then in a moment a worded one, and then hopefully you'll have a better understanding of how to approach these questions where, as I said, the maths isn't obvious on what we're going to do. So let's have a look at this example. The diagram shows two identical squares placed side by side to form a rectangle, and then we've got a diagram. All measurements are in centimetres. Calculate the numerical value of the length of the rectangle. Now, what would appear here to be a perimeter or an area question, because we've got a shape and we've got the dimensions of those, isn't necessarily going to be the case. So I know a lot of students would approach this question by saying, right, well, I've got the dimensions here, therefore I should be able to find an expression for the perimeter, but nowhere in the wording of the question is the perimeter mentioned. So maybe they'll attack it in a different way and say, right, well, I've got the dimensions, so perhaps I can find an expression for the area of the rectangle. But again, nowhere in the question is the area mentioned. So there's a bit of a stumbling block here. What do we know? What can we do? Now, my go-to with these questions, my general rule for these questions is think about setting up an equation. Always try and form an equation, because this X thing stands for something. We're probably going to want to find out what it is at some point. So let's have a look what we do know in this question. We know we've got two squares, and we know that in the properties of a square, sides are the same length. We've got two squares next to each other, and their total distance is given by this. So what we could do, and that may prove to be useful in a moment, is we could break them down by halving it into this one must be 5x take 1, and this one must be 5x take 1. Together, two lots of this would make 10x take 2. What we can then further break down is that we've got a square, and as we said, the properties of a square are that the side lengths are the same. And in maths, if we're saying things are the same, we can say that they're equal. So what we can now do is we can form our equation. We've got one of the side length of the square as 5x subtract 1, and it's equal to 3x plus 5, because that's an expression for the other side length. So these two both come from the sides of a square. The sides of a square are equal, so these two expressions have the same value. That then leads us nicely into forming an equation which we can solve using the balancing method, and then we can find the value of x, and that's the key part to these types of questions. So, solving this linear equation, I've got x's on both sides, so I'm going to eliminate the lower amount. So I'm going to take away 3x's, but I'm going to do that to both sides, otherwise it's not going to be balanced anymore. So on the left-hand side, I've got 5x subtract 3x, which is 2x. I haven't touched the subtract 1 yet, so that's still there. On the right-hand side, I've got 3x subtract 3x, which is nothing, they're eliminated, and I've still got this positive 5. And I've still got a lovely balanced equation because I've done the same thing to both sides. So it's looking a lot more simplified now. It's not perfect. I don't know what x equals yet, but I'm well on my way. So the next thing I want to get rid of is this subtract 1. And we do the inverse operation. So we're going to add 1. And again, I'm going to do that to both sides to keep it balanced. So I've now got 2x. This minus 1 and this add 1 cancel each other out. And it's equal to 5 plus 1, 6. And you're probably already looking at that and you know the solution, but let's finish it off properly. If 2 lots of x equals 6, but I only want to know what 1 lot is, I'm going to have to get rid of this times by 2. So I'm going to divide by 2, again, both sides. And therefore I've got 2x divided by 2x divided by 2 is x, and 6 divided by 2 is 3. So I now have the value of x. So let's just double check in our question. Is that what we were asked to find? Does it say find the value of x? Well, no, it doesn't. It says calculate the numerical value of the length of the rectangle. So we're going to use x, but that's not our final answer. So let's go back to our diagram. The algebraic expression for the length of the rectangle was this: 10 lots of x take 2. We now know x is worth 3. So 10 lots of x take 2, where x is 3. That means the 3 can go in there and replace x. So instead of 10 lots of x, that's going to become 10 lots of 3, because x is worth 3, and then I'm going to subtract 2 from that. So 10 lots of 3, 30, take 2, my final answer, the numerical value of the length of the rectangle is 28. Right, let's have a look at another one of these questions where Again, approaching it in your GCSE, you might not be entirely sure what sort of maths the question is asking us to do. And as I said in the previous question, my starting point for these is always to think about forming an equation, setting up some kind of maths that I can work out the value of something. So let's have a look. Malcolm knows he eats too many biscuits. He wants to eat less than 30 in a week. On Monday, Malcolm ate some biscuits. Now, we know that there is a number here. We don't know what it is yet, but we know there's a number here. And in maths, when we don't know something, we use an algebraic term to represent it. So I'm going to say on Monday, Malcolm ate X biscuits. Excuse me. Then I can compare the rest of the question to Monday's biscuits. I don't know what X represents yet, but at least it allows me to construct the rest of the question. So, Monday he ate X biscuits. Tuesday he ate half as many of this. So he ate half of X. On Wednesday he ate 5 less than Tuesday. So let's be careful here. This one's not comparing it back to X. This one's comparing it back to Tuesday. And on Tuesday he ate half of X. And now he's eaten 5 less than that. We can represent that as take away 5. Thursday he ate 9 biscuits, just 9 biscuits, nothing again to do with X, just 9 biscuits. Friday, Saturday, Sunday he ate no biscuits, so we can ignore those. Malcolm ate less than 30 biscuits in the week. So what we do know is that if we took Monday's biscuits, which is X, and we added Tuesday's biscuits, which is half X, and we added Wednesday's biscuits, which is half X take 5, and we added Thursday's biscuits, and we added Friday, Saturday and Sunday, but that's nothing, then all of that is going to be less than 30 biscuits. And we've now established an equation. Instead of an equal sign, we've got an inequality sign, but we still approach them in the same way. So now I've got an equation that I can solve. So let's start by tidying this up, because this looks quite complicated. So I've got an X, and I add half of an X, so that's 1.5 X. And I add another half of an X, so that's now 2 X's. And I've got negative 5 add 9, well that's going to take me up to plus 4. And that has to be less than 30. So now I've got my equation and I can solve it just like I did on the previous question. So let's have a go at balancing this. So I've got 2 sides to my balanced equation. I'm lining up here where the equal sign would be. It's just on this occasion it's an inequality. And the first thing I want to eliminate is this plus 4. So I'm going to subtract 4. Again from both sides, otherwise it's no longer going to be balanced. So I end up with 2x has to be less than 26. And I've done the same thing to both sides, so it's still balanced. And then finally I need to get rid of this times by 2, so I'm going to divide by 2. Again, do it to both sides. So I end up with a solution of x has to be less than 13. Now, let's think very carefully about what that means in terms of our question about Malcolm and his biscuits. X represents the amount of biscuits he ate on Monday. The question is, what is the biggest number of biscuits Malcolm could have eaten on Monday? Well, if x was 13 biscuits, it wouldn't have worked, because if we use our equation, he would have eaten exactly 30 biscuits across the week, and it says he ate less than them. So we're looking for x to be a number that's less than 13, but obviously being a biscuit, it's going to have to be a whole number. So we're going to have to ask ourselves, what whole number is less than 13? And the closest number I can come up with is 12. 12 is the integer that's underneath 13. So 12 biscuits is the number that Malcolm ate on Thursday, and we can always substitute that back in to check that he didn't eat more than 30 biscuits across the week. I hope that video's helped. As I said, the key to these questions is to use some algebra to represent things we don't know, and your priority is always to form an equation so you can work out the value of that missing letter. Thanks very much for watching.